Okay, so in this final section, we're going to be looking at fiber optic sensors. So when we started with applications, I told you there are two main applications of fiber optics. One is in communication. We looked at the telecommunication block diagram, and the other is sensors. So we're going to look at how this idea of TIR and fiber optic cables is used for sensors. So there are two types of fiber optic sensors, passive sensors and active sensors. So the core idea behind both is there is one physical quantity which you are trying to measure or sense. For example, temperature, pressure, strain, whatever. So you have a fiber optic cable, you couple light into it, and then the light travels through it and comes out. Meanwhile, you change this physical quantity as in you increase or decrease the temperature, or you apply pressure, or you remove some pressure, or whatever it is which you are trying to measure, you change that quantity. And then you see some changes either in the power output of the light or in the intrinsic properties of the light itself, like its phase, wavelength, something changes. So depending upon the change in the light, we measure the change in the physical property which we were trying to measure. That is the core idea behind fiber optic sensors. So they are classified into extrinsic and intrinsic sensors. Extrinsic sensors or passive sensors, they only act as a passage for the light to go through. So what I mean by that is, the light passes through as usual, and then I am changing something, such as, let's say I am raising the temperature. The intrinsic properties of the light itself are not going to change. The wavelength of the light, the intensity of the light, the phase of the light wave, these are not going to change. But when the light comes out, the power output will be different. It might be more or less. So depending upon the P out by P in ratio, we will calculate the temperature new minus temperature old, or the change in temperature. So essentially what your extrinsic sensor does is, it makes sure that the inherent properties of the light do not get altered, only the power output changes, and the power output is what you use to measure the change in the physical quantity in case of an extrinsic sensor. On the contrary, when you take an intrinsic sensor, the inherent properties of the light itself change. For example, again I have an intrinsic sensor fiber optic cable this time, and I am coupling light into it. Then I raise the temperature. Then I see that either the phase of the light changes, or its intensity changes, or its wavelength. Something inherent to the light itself changes. The change is not restricted to the power output alone. So those are two types of sensors. So these are just examples which you can go through. So coming to active or intrinsic sensors, there are different types: single point sensor, multi-point sensor, and distributed sensor. So what it says is, the single point sensor, the sensor is located only at one location. With this is your entire cable. So the sensing element is located only here. Multi-point sensor, the sensing element is located at different discrete points within the table. And distributed sensor, it's a continuous cable. Like throughout the cable you have these sensing elements, meaning at every point the change is being sensed. In this one, only at these points the change is measured, and this one, only one point the change is being measured at all. So those are just subtypes. You will not be questioned too much in detail on these, but it's good to know that these types exist. So this is the Mach Zehnder interferometer, which is an expected 10 mark question. We'll come back to that, but before that we'll finish temperature sensors.